Hey, what's up guys? My name is the Cherno, back at it again with one of these sweet code review videos. This is just a little series on my channel where you guys send me some code and I take a look at it. Now, last time was the first episode of this series. I'll have it linked up there, and since then there have been quite a lot of submissions from you guys as well as some questions as to what kind of code I'll be looking at, so I'll try and answer that today. But the short answer is, if you want me to review your code, check out the email address in the description below. It's, chernoreview@gmail.com. You can send your code there, as well as a little description of what the code actually is and if there's a specific area that you want me to review in particular. Now, the first thing I want to mention is there have been like a lot of submissions, and it's a little bit difficult for me to obviously pick one and review it. My area of expertise is of course game engines, so I do like looking at game engines, but that is not the only thing I want to look at. We are going to be looking at another game engine. Last time we covered like a 2D game engine made by a 13-year-old. This person is 17. We'll dive into this email in a minute. And this is, as far as I'm concerned, a 3D game engine kind of based on Hazel. So this should be a little bit of familiar code. Maybe this, my hope is that this kind of code review will hopefully help guide some of the people who are following my game engine series, but also trying to write some of their own code. Because for those of you who don't know, of course, I do have a game engine series here on YouTube. But if you have a project that is in another language, if you have a project that is just a game or a game engine or an implementation of some algorithm and like a visualizer to go with it, feel free to send that as well. It doesn't have to be game engine, it doesn't have to be C++. But anyway, I don't want to spend half an hour talking about this series in general. If you have some code that you want me to review, check the email address in the description of the video. Let's dive in and take a look at Dmitry Vasilyev. So, Dmitry is from Ukraine, which is pretty cool, and he's 17. So a little bit of a age difference between 13-year-old, but still not like professional code, right? I'm kind of building towards that. Maybe we'll get into like someone who is like some engineer at a company and they have a hobby project and they want me to code review that. That would be interesting as well. But you know, this should be a step up from the 13-year-old code that we looked at last time. By the way, a little bit of a precursor. I'm assuming that they're more experienced because they're older. That's not necessarily the case, so actually I could be wrong. I'm currently working on my own game engine because it's a great practice project. I want to be an engine developer. Maybe there's a chance for me to write something new and amazing for the industry. It now can render a rotating cube and much more, maybe when a test engine sandbox with rotating cube. Okay, cube implies 3D, so this should be in fact a 3D engine. I want to improve every aspect of engine, so I'll be very grateful if you can point out my mistakes and explain how to fix them. Link to GitHub repository is here. Let me look at that, and you'll find all instructions inside. Thank you a lot for your content and this review. Sorry for my English, working on it. People who don't speak English as a first language always say this, and their English is usually very good, so yeah, well done. Okay, so here we have the code. Looks like CMake is in use here, and we can clone it recursively. And there are actually build instructions, which is pretty good. I think that's more than Hazel has. CMake 3.17, clone, standard CMake stuff here. And if you build a sandbox project, we need to add this option. Okay, so good thing I read this. Or you can use CLine, all right? And then we can generate this. Okay, so we're gonna dive in and generate a Visual Studio solution file with the sandbox project, I guess, and we'll try and compile it and run it first. I might just skip past that part, and then we'll actually dive in and look at the code. But first, this video is sponsored by Skillshare. For those of you who still don't know what Skillshare is an amazing online learning community where millions of creative and curious people from all around the world can come together and learn some new skills, because learning new skills is both fun and incredibly helpful in life. Now, whilst I'm from Melbourne, Australia, and we're finally coming out of our lockdown, I know that Europe's kind of going into a bit of a lockdown at the moment. And one of the things that I actually did to help me get through lockdown was I tried to be productive. Right? If you are stuck at home and you can't go outside and you can't hang out with your friends as much, then instead of just watching Netflix, just binge watching it the whole way through and then feeling bad about yourself, you can actually use some of that time to do something productive and learn a new skill. I know that makes me feel a lot better, and I stay a lot healthier mentally. And that of course is where Skillshare comes in. They have thousands of amazing classes on pretty much any topic you could think of, whether you're interested in art or illustration, or like logo design, or business and marketing, or productivity, or photography, or editing photos, or anything like that. They have a bunch of amazing classes. For me, one of my personal favorites is this art and illustration course by Jazza. Jazza has a YouTube channel. I'm sure a lot of people have heard of him, but he also has this amazing, like really well put together Skillshare course, which can function as a really good introduction to illustration and just drawing in general, which is something that I love to do for fun, just to chill out after a long day. And I love the fact that the classes are so bite-sized. A lot of the videos in the classes are like between 5 and 10 minutes. So even if you just have a few minutes at the end of the day, it's so easy to sit down and actually do something productive. For a limited time, Skillshare is offering you guys a free trial, so definitely jump on that link in the description below, check it out, see what kind of courses Skillshare has in general, and go ahead and learn some new skills. Huge thank you to Skillshare as always for sponsoring this video. Now, the first thing I want to do with this is obviously try and build it according to these settings. I just want to start off by saying that even though we're not into the code, this kind of documentation is great, right? When I look at a repository like this, the first thing that I want to see is what the project is, which it clearly states, and a getting started guide that actually has instructions on how to obtain it and how to build it. These instructions aren't that long, so he could have left them here, but I mean, it doesn't matter at all. The point is that they're here. It's really easy to actually build this project. The instructions are all here. There's even a plan and a cute little mention to my Hazel videos, so thank you for that. But my point is, it's really nicely organized and I don't have to think twice about what on earth this even is. Now, once the project matures a little bit more, it's really nice to see a screenshot of what it's capable of rendering. Now, I don't do this in Hazel. If we look at Hazel, it's just kind of got like the logo here, and then that's kind of it. I mean, it's got instructions on getting started, as you can see, and the plan as well, and all of that stuff, but it doesn't have a screenshot. We're not really rendering anything exciting yet. I don't think he is either, but that's just something to keep in mind for the future. If you're actually working on something visual, then it's good to include some screenshots. Okay, so I'm gonna grab the link. I've got a little, let's call this, we'll just clone it over here. So I'll just make a, I'll open a command prompt here, git clone recursive, we'll dump that in here, and then we will, once this clones, we'll compile it with CMake. This was actually quite fast, so I'll probably just not even have to skip through this. Okay, so let's take a look at this in the meantime. So we've got GLAD, we've got GLFW, we've got GLM, we've got IMGUI, we've got SPD log, speed log. This is basically the same setup as Hazel. It does say that it's inspired by Hazel, so we'll see what kind of modifications he's made. For the record, a lot of people tend to ask me if it's okay for them to kind of copy Hazel. Like, of course it is, right? This is a tutorial series for you guys. My hope is that you would take what you like from it and then maybe change some things that you don't like and then add a whole bunch of your own stuff to it. You know, there's no reason to ask me if it's okay to copy the code. Now, if you just copy the whole repository and then just change the name from Hazel to Walnut Engine or something like that, I don't know, then that's kind of like, that's a bit lame. You know, it's not very cool. But if you're obviously learning from it and then molding it into your own work, that's kind of the idea. So let's make a directory called build. We'll go into build and then we'll just run CMake like that. Subdirectory, okay, I just completely failed there. Let's actually go into, what was it called? Real Engine, and then we'll make our build directory, and then we'll go into the build directory, and then we'll CMake. There we go. Okay, so whoa, okay, let's stop. I remembered. So this is why it's so good to read the instructions. You need to add this. Let's go ahead and add that. So CMake ... paste. Okay. So this should also, I guess, include the build examples, which is going to be good. Or rather, it's going to include the examples. Okay, and of course it hasn't worked. Now, even though CMake seems to have failed, it does seem to have generated like a solution file. I might just open that. I don't really like debugging CMake. I don't think anyone does. It looks like it's saying that CMake may not be built correctly, but I'm pretty sure I've been using it for a while on this computer. So a little bit weird. On a side note, this is why I love Premake so much. I have had pretty much 0 issues with Premake and all the issues with CMake. Okay, so real engine, I guess we'll look at the cube example. Hopefully this will just build. I'm not sure if it will because of the CMake issues I described earlier, but let's take a look at this. Okay, so there's a bunch of custom build rules for all of these different projects because I imagine they also support CMake, which is nice. One of the downsides, obviously, with using something like Premake is you have to write scripts for anything that doesn't include it, whereas CMake is pretty much standard. So that's definitely helping out in this example. And if we hit F5, hopefully this will run. There we go, it runs. Now I can't open shaders base GLSL. So it looks like we can't load a shader file. Interestingly enough, though, it didn't crash or anything like that, which is nice. It's just running with a black screen. Let's see if I can quickly diagnose this and have it actually open the file. So it's supposed to be in shaders. Let's see what the working directory is set to. So right-click properties, debugging working directory is set to the bin folder. This might actually be the issue because perhaps, here it is. So in the bin folder, there's debug shaders and then shaders in here is empty. So this should probably be the working directory. So it's just missing a debug. Yeah, a little bit weird. Again, this might have been a CMake thing. I'll just set it manually because this is a code review and I just want to see it running properly. There we go. Okay, so a bit of a white cube here. I guess the shaders is just setting a flat color, and everything else looks pretty good. Obviously similar to Hazel here with like the logging and the different coloring and all of that stuff, but we have a point to get started. So the next step for me here is going to be just to dive in and take a look at the general structure of things. Now I already imagined that this is going to be fairly similar to Hazel, which is kind of making me think that maybe this was almost a mistake picking this one because it's probably going to have a very similar kind of layout, but maybe I'm wrong. Maybe there's been some stuff that's been added. Let's take a look at this. Obviously the big thing that I'm looking for is the fact that the Hazel and the Game Engine series on YouTube is not 3D yet, whereas this seems to be 3D. So I'm interested to see how this person has actually kind of integrated 3D rendering, even though it is just a flatly lit kind of, or a flat shaded white cube. And we'll see if we can review that code specifically. Okay, so this is the main example of the real example cube. Now, obviously I'm seeing a lot of kind of engine code inside this, even though it is an example. So that's kind of the first thing I'll point out. You know, there's like setting up the actual cube here, application init. These are all things that I don't like to do inside the actual client app, so to speak. Now, the reason is that application init from within this real engine, this is something that I have no doubt has to happen for every single application. So if this is just like part of the engine startup, why is it the application's responsibility to call that? You know, there's no way around calling application init. Right, I imagine that this absolutely has to be called. I mean, this initializes the renderer, the window, all of that stuff. So why have it here? Why not have it as part of the engine startup? Now, I don't know, maybe I should bring up Hazel and kind of talk about the architecture with that, but we'll see. If you guys have any ideas for how I can maybe be more effective in these code reviews and what stuff you're interested in, then definitely leave a comment below, but I'll just kind of take this as it is for now. Okay, shader library load. Okay. My first question is immediately, where does the shader library come from, right? Because this is a variable. We're in the init function. This is a variable, right? So it's a pointer in this case. It's a real reference, which is just a shared pointer. So we do a similar thing, of course, within Hazel. But you can see that just kind of in this private section of this class, where we're just creating this right over here. Now that might be okay because shader library is just a, like it's a very kind of, straightforward, kind of simple to initialize class, right? Simple to instantiate class. It's not like it does any kind of OpenGL code or anything that's dependent on anything else. It just creates an empty unordered map and that's it. So it's totally fine to initialize it here, but then my second question is, why is it a reference? Why is it a shared pointer? I don't imagine this would get passed anywhere. And you can see it doesn't. So my first kind of advice would be probably just get rid of this, you know, just have a stack allocated shader library like that. And then you don't have to allocate it on the heap. And it's a lot simpler. I mean, it doesn't change like the actual kind of API that much, right? But it's something that you just don't need to do and that you shouldn't make a habit out of. Same with all of these, like, you know, these might be passed into an API that expects like a shared pointer or a reference counted object, and that's fine, in which case I would create them on the heap. But, you know, for the most part, these are probably not going to suffer if you don't create them on the heap, especially for this example. Yeah, so you can see kind of in this case, right? Add index buffer takes a reference in. So, you know, unless you want to write your API twice, it's just best to just stick with references, and I get that, that's totally fine. Also, I won't jump ahead. Let's continue going over here. Okay, so we load this shader, sure, fine. Now this is a shader library, so I wonder how this person's gonna reference this next. So obviously we're taking a file name here. Does it automatically get the name from the file? Like how do we, a library obviously implies to me that we have a library filled with shaders and we want to be able to retrieve shaders later. So how do we retrieve them? Shader name seems to be a function. Potentially, I can't really go to it, unfortunately. Shader name, here it is, and then name gets set here, and I imagine that maybe it's just the file name. Yep, so I think we do a similar thing in Hazel, or at least in Hazel Dev. So in other words, this would probably treat it as base, and if I want to get in the future, I can just retrieve the base shader, so that's fine. Okay, setting up rendering here, so we have a bunch of vertices for our cube, and we have a bunch of, well, it's called positions, but these are indices, so I would definitely rename them to indices because whilst I guess technically speaking these are vertex positions and there's no colors or whatever in here, It's probably not great to have them like this. Also, keep in mind this cube isn't really going to work. So what you've done is you've got a total of 8 vertices here describing the cube. I mean, for a cube, there's maybe lit like with a flat color, or in your shader you're just setting it to white. That's totally fine. You can physically get it to render. But when you start to do any kind of lighting calculations, you'll need to have normals, and normals, you can't have one normal per each kind of vertex in this case. Here, let me just illustrate this. This is something that a lot of people get wrong. So if we have a cube, pretend that this is a cube, and we've decided to have a total of 8 kind of vertices here. So if you kind of draw the cube, you wind up with a cube technically, because you really only need 8 of them, right? So it looks something like this, and you obviously have your cube and it looks like a cube. The problem is that when you want to start doing lighting, you'll need to actually know which direction all of these faces are facing in, so that you can see how much they're facing the light, right? So to do that, you'll need normals, and normals point in the direction of the face. Now, if you've only got one vertex, you can only have one vertex normal, which doesn't really make sense, because even though it has physically one position, if you think about it, it's part of this face, which is pointing this way, it's part of this face, which is pointing this way, and then it's also part of that kind of back face that's pointing that way, right? So in actual fact, you need 3 vertices in this one place. They have the same position, but they have different normals. Now, there are no normals here, which is why it's working fine, and consequently you can see that you're not doing any kind of lighting in that flat white cube that we looked at earlier. But for the future, this is something that you'll need. So in other words, even though you might think that you can get away with 8 vertices for a cube, in reality you'll need 24 of them, because you need to, there are still some that you can duplicate. So in other words, if we have kind of a triangle, if we have this face which is made up of 2 triangles, we only really need 4 vertices to represent this, because even though we have 2 vertices here that are the same, one belonging to this triangle, one belonging to this triangle, they still are facing the same direction, so we can get away with them having the same normals. But, you know, when you're talking about all of these different faces facing different ways, you'll need more than that. So that's just a little bit of information regarding cubes, because I remember back in the day I used to struggle with this as well. I thought, why on earth would I need more than 8 vertices to represent a cube? There's just 8 points in 3D space, and that's correct. But again, a vertex is not just a position. It can have other data attached to it, such as a normal. And if you want to have different data per vertex, then you might have to duplicate the position, because it's not just all about the position. Okay, back to the code, positions. Yeah, so these are all the indices. Now, just a little quick note, I would probably recommend just, once you have like the ability to load 3D models, it would be very useful to actually just load a 3D model that contains all of this in it. The reason is that writing stuff out like this is kind of useful, and a lot of engines have something called a mesh factory that can generate this, but it is also a little bit of a headache. I don't know, I'm kind of torn on this, because on one hand it's good to learn about this, and it's good to learn about how you can manually like position a cube, but it's also like very tedious, I think, for a beginner to do. I'm not sure. Leave a comment below with whether or not you think a beginner will say, I'm not sure if, I'm not calling this person a beginner, but for the sake of this example, we'll pretend that they're a beginner. Is it a good idea for a beginner to be kind of manually, you know, building meshes up like this, or should they just try and load a 3D model? What's better? Because I can't really decide. One thing I do want to note that I could probably keep talking about this cube for like the whole video, but one thing I'm also noticing here is it's not like a 1x1 meter cube. So generally when we have like basic primitive types, basic meshes, we want them to be some kind of consistent size, usually about 1 meter in either like, you know, the diameter or the radius. You can decide which one you want, usually the whole diameter would be 1 meter. And then also like for this, you'd probably want the cube to be 1x1 meter, right? Or 1x1 centimeter, depending on what units you're using. This is obviously 2x2, right? Because we go from +1 to -1. The problem with this is that it can throw off the scale of the rest of your 3D rendering. Scale is something that's really important. Scale is something that people don't really think about that often either. But just know that when you're making stuff like this, you should just make it kind of, you know, be, I guess, 1x1 unit. And then you can obviously scale it to whatever size you want. Okay, positions, sure, we've gone through that. Okay, VAO reset. See, this is like another kind of consequence of using these shared pointers. I'm not a huge fan of calling reset. You can probably just set it equal to something like this, right? And you might have to do like a make shared, and I guess that's probably why you've done it this way. But I just think dot reset looks a little bit messy, because you're basically substituting like an assignment, like an equal sign for a function called reset. Bind, not sure why you're binding here. So see, this is just another example of like an API that's doing too much in the client, right? What you probably should do is, like, if you really do want to construct your own vertex array and then your own kind of vertex buffer and index buffer, then what you should do instead is, well, we can get into this stuff in a minute, but what you can do instead is just maybe add them correctly like that without having to like bind them. Then this does any kind of binding it needs to if you actually want to, like, for example, link the index buffer to a vertex array, because the like one of the ways that you do that is by actually just binding the vertex array and then binding the index buffer, and then it magically links. OpenGL is annoying. But anyway, that's a lot better without having to kind of, I guess, put that responsibility onto the client. Because if you look at this, you know, this becomes a little bit complicated already, right? Like if I want to render a cube, this data is kind of necessary, because for the sake of this, we'll pretend that instead of being like, this is how my engine renders a cube, because that's a bit ridiculous. You don't want to have to write out all this code to render a cube. Let's pretend that kind of, for the sake of this, that this is how our engine renders a custom shape in which we provide the vertices and the indices, right? So if this is our custom data that we're providing, that obviously needs to be there. But then this, I think, could be a lot more simplified. So you could, for example, make a vertex array. Don't worry about binding it. You can set the layout, because that needs to be done into the vertex buffer. This code needs to be here, obviously. And then this code needs to be here, obviously, right? And then I guess you need to add it somehow. But like all the kind of binding and the, you know, that stuff doesn't need to be here. You want to keep it as simple as possible. You could even write a kind of constructor for a vertex array that actually takes in a vertex buffer and an index buffer and like a layout or something like that, so that it's really easy to just be like, hey, I have this information, right? I have this data, and this is my layout. That's my vertex array. Please, like, save this so that I can use it to render later. Man, these code reviews are getting difficult. If you guys, let me know what you think. If you guys are okay with like a 1 hour code review every time I do this, then please let me know, because I kind of consciously want to keep this under 20 minutes, but it's impossible to review a 3D engine, or even like something of this size, which isn't that big, in this amount of time. Maybe I'm just going through this way too finely, but it's kind of fun, and I'm seeing a lot of things here. Okay, I want to mention that using the standard math library, not the biggest defense, but you've got GLM. Use GLM, right? You've got a math library that presumably supports like intrinsics and SSE and all that stuff. I don't know if the standard library supports that stuff, to be honest. So maybe I'm wrong, but I would use GLM instead of all of this stuff, just to be consistent with your math library as well. Not to mention that, you know, if you use the standard math library, you're kind of leaving that up to the compiler. So you might see different speeds across different platforms with different compilers, whereas, you know, GLM is presumably going to be stable. Okay, camera position, camera lookout. So what this, yep, okay, so we're looking at a point. This is probably just going to do a lookout matrix, yep. All right, cool, update view projection, and then we create a projection times view. Okay, sure, pretty standard camera class here. Render. Okay, so this is interesting, right? So we start a scene, we get our transform. So this is going to be, oh, we actually have a transform. So transform is a matrix here with a little no discard attribute. That's cute. I don't usually use them that often, but they're not bad, obviously, to use. Probably a good thing. Then we take in a transform here. I would probably try and avoid copying this, by the way. So taking this in by const reference is probably a good idea, so that we don't necessarily copy it. Either that, or you could take it in as like an R value reference if you want. If you've got some kind of local kind of variable that you want to just move into there. The point being that it is 64 bytes, so it's probably worth saving the copy there. Initializing to identity by default. So this is, again, something that I would reconsider. The reason being that you've only got a single constructor that is taking in a transform, right? So this actually does nothing at the moment. It might as well not be here, because you're setting the transform to be whatever you take in the constructor. So this is just kind of just empty code that you know, is misleading, because when you look at this, you're like, oh, by default is identity, but actually it's not. It's whatever you specify here. I'm not even sure if I would necessarily have this class, because literally it's a matrix. It's just a wrapper over mat4. and I definitely like to not clutter my code with things like this. Okay, submit. So we submit a vertex array. We get that base shader. There we go. That's what I was talking about. And then we submit a transform. So pretty simple, right? We have a vertex array, which contains the buffer, the vertex buffer, and the index buffer. So we have all the information we need there to render the object. We specify the, we'll say, material that we want to render it with, which is the shader in this case. And then transform is the transform of the object. Where do we want to render it in our 3D scene? And then of course we start the scene with a camera. So fairly kind of standard, I'll say, straightforward render design here, where we start like a rendering context with like our camera and our environment scene setup. And then we obviously proceed to actually submitting entities for rendering by specifying both their actual physical like vertex buffer information, as well as things like materials and transforms. Okay, and then we end scene. I'm interested to see what this does. Yep, okay, so we're just literally taking the view projection of the camera and I guess copying it into the data. End scene does nothing. I had a feeling it would do nothing. And then we of course set up our uniform matrices from this shader, obviously assuming that they're there, and then calling render command draw index, again very similar to Hazel, and then that will actually, okay, set polygon mode to fill so that we get filled rasterized triangles here and not wireframe or anything like that, and then draw elements in a pretty standard way. Yeah, I mean, look, pretty simple, pretty effective, I think. Obviously, there's a lot of things that you would want to change in the future, but you probably understand that, and this is obviously a work in progress. You know, things like assuming the primitive type, as well as assuming the fact that it's an unsigned int and not like an unsigned short. So, because obviously we can have, you know, like 16-bit indices, 32-bit indices, stuff like that. And then obviously the fact that we might not want to render the entire vertex array at once in one draw call. So we might have like a mesh with multiple different materials in it, for example. But other than that, you know, it's pretty simple. I would say this almost does too much for a draw indexed command, because in Hazel, usually I like to keep these as separate commands, but I think it's okay for this, not a big deal. Default clear bits, enum val, okay, it just returns GL. Oh, right, that's the enum value of this API. I noticed your code convention is a bit interesting as well. Usually we like to like capitalize classes. You know, the fact that you're using like snake case for this is totally fine. A lot of people do that, but I definitely have to say I don't like classes not being capitalized. I would definitely capitalize them, because otherwise you literally can't tell the difference between a class and a variable name or a type name or like a, you know, function, and it just gets a little bit confusing. But other than that, yeah, it looks pretty solid, to be honest. If we look at real API and just see what it kind of maps to here, so we're doing DLL export, so I guess we're compiling real as a DLL, which is fine. And I think I've covered pretty much everything. And then, of course, we have like an event kind of process. Again, things like, you know, EV, like I would just write the word event, you know, like this, to make it really quite simple to understand. Because in general, like, I mean, I personally believe that writing code, you know, you don't want to write overly verbose code, but in my experience, it's better to just write code that might be a little bit longer, but make a lot more sense than code that is short and only makes sense to you, and also you might forget about it in the future. I mean, obviously on event, we take in an event. I guessed that this is an event. It's not particularly difficult to read, but still, like, I mean, you know, try and avoid classes called EV, because I think that that's just, you know, unnecessarily difficult to read. Okay, then we've got a bunch of, and this is kind of part of the event class, looks similar to Hazel's event class. There's a few differences here, I guess. Is event, yep, so that we can just kind of process different types and make sure that we are in fact dealing with something that is a derived class from our base event class. Okay, cool. Yeah, pretty standard, I think, pretty simple. Windows window. So I guess this is the window data for the window. Okay, so we have a client window and we derive from the kind of game engine window. Okay, that's interesting. Window dimension T. I would also say avoid so many custom types, right? So key code T, mouse button T, mouse position T, window dimension T, window position T. Like, this is all very unnecessary. Just have a just use uint32t or int32t or just int even. I mean, if it's not a big deal and you don't really care about like the exact number of bits. I think that in general, like I remember when I was a little bit younger and I was learning about C++ and I'm like, oh my goodness, you can make any type you want. I probably also went crazy and made a billion types. Don't do that. It's really annoying, and it doesn't help at all. So just, change this to just be either an int32t or even just an int, or I mean, like a window width can't really be negative, so I'd probably write something like uint32t like that, really easy to understand, and you don't have to have long names. Here you use a long name, but event gets shortened to ev. So yeah. Okay, we got some moves going on here, so that's kind of nice. I was going to say that in general strings, I like taking strings in by const reference most of the time. This is a good opportunity or a good place to not do that, right? So if you take it in by value, it's a lot easier to kind of move it in here, presuming that we move it into title, into this constructor in the first place, which might not happen. But there are some optimizations you can do with move semantics if you take strings by value. So I don't want to say that it's like a hard rule that strings have to be const reference, because they don't. And in a lot of cases you can get away with, well, rather it will be preferable to take them in by either value or like as a string view or something like that. I don't want to really get into too much of that, but my point is, this is interesting. This is nice to see as well. And then, yeah, I don't know, things like moving callbacks, like I'm not sure that I would do that. But I guess it's definitely not harmful. Okay. Blah, blah, blah. Okay. So I mean, in general, I'm just seeing an extraordinarily large window class. Like, why is this stuff not in the base window? Like, this is, this almost feels like Windows window. Oh, it is Windows window. Okay, right. This is Windows window. It's just that it's inside the example, or at least, is it inside the example? Maybe it's just like linked somehow. Yeah, it doesn't look like it is. CMake's just included this. Okay, never mind. So this isn't actually in this. If we look at where the file resides in, it's actually inside the real engine. Inside the engine. I thought that it was inside the example project, because that's what maybe CMake has included it, because I guess it's used inside main in some way or another. Anyway, it's a bit weird seeing it here, but I guess that makes sense. That's very similar again to Hazel. And then we've got input again with the positions, with the custom types. I would get rid of those. And also I wouldn't use, I don't know if I noticed this before actually, but I wouldn't use header guards like this anymore. It's not like the 90s. I would just write pragma once, because I know that it's technically not part of the standard or whatever, but it's supported by every compiler and pretty much everyone uses it. So I would just use pragma once. Okay, cool. I think that pretty much covers it. So in general, I mean, I guess good work. I definitely question some of your naming conventions and some of your kind of different types that you've made. As well as just some of the API design. Obviously this is all work in progress, and you did mention that you're 17 and you're just kind of inspired by Hazel and following along. So for that, obviously you've done a really good job. Clearly very heavily inspired by Hazel, and there's a lot of architecture that's very similar to that, which is obviously nice to see, because that's the point of making the game engine series in the future. For those of you watching, let me know if there's something in the code that I've missed maybe, and that you noticed that I should point out, or that you wanted to point out. I want this to be more of a community thing. I mentioned this before, but I'm not like some kind of C++ god that just corrects people's codes in absolute perfect kind of fashion. This is all my opinion. If you disagree with it, leave a comment below, share your thoughts instead. And then we can kind of, even though it's me looking at this, it's kind of, I guess, us doing it together. And I was even thinking about adapting this to be more of like a live stream format, maybe right even here on this YouTube channel, so that it can just get, proceed to be like a YouTube video once it's done. But with kind of like chat or something like that. We'll think about the format in the future. But in general, let me know what you thought of this code review. If you did enjoy it, please don't forget to hit the like button. If you have some code that you want me to check out, submit it below. I'll try not to do a game engine next time. I would love to like look at a little game, maybe. Or just some other kind of cool project that you've made. So if you've got something interesting, then definitely submit it. And also, one thing that I've kind of realized throughout this episode is that maybe it's a good idea for me to kind of pick a subject just while I'm going through code in like one of these code review episodes. Just like pick a subject, like in this case it was almost like the cube, right? And just hone in on that and talk about that kind of in more depth, rather than trying to quickly read through all of the engine code. And I don't know, with this project, I felt like it was a little bit more, I guess, overwhelming to try and get through it in a timely fashion than like the other projects. And I think that maybe it would be more useful to people if I just kind of used the code as an example and maybe just gave a brief overview of the coding style and just the different kind of way that it's architected, but then also, you know, focus in on something specific. So let me know what you think in the comment section below. Don't forget that you can get a free trial for Skillshare by using my link in the description below, and I will see you guys next time. Goodbye.